We have spoken about HSRP in our previous video, but there are really a few more things that we need to cover. So the first thing we will have a look is HSRP interface tracking. So HSRP interface tracking is a feature that allows a router to change its HSRP priority based on the availability of its interfaces. So you can configure HSRP to track the status of one or more interfaces. So if a tracked interface goes down, the HSRP priority of the router decreases, making it less likely to be elected as the active router. Okay, so when a tracked interface goes down, the router's HSRP priority is reduced by a pre-configured amount. This helps prevent traffic from being routed to a router that might not have connectivity due to the failure of a critical interface. So when the tracked interface comes back up, the router's HSRP priority is increased back to its original value, allowing it to potentially become the active router again. Okay, so here is how it is working in reality. So if you are seeing this image on the right of the screen, I can see that there is a local area network, and we have our router A and we have our router B, and they are running both HSRP protocol. How I know it? Because I know their configuration, router A and router B. So router A is configured with a standby IP of 101, same applies to router B, and router A is configured with the preemption, but there's something else configured with router A, standby track serial 00, and there's something 10. What is it? We will have a look. Router B, on the other hand, it is configured with priority of 95, and we know that default priority for HSRP is 100. So in this scenario, in first place, router A is my active router because it has a default value of priority, which is 100, right? On the other hand, this is also configured with standby track serial 0010 command. Okay, so let's say whenever everything is working fine, HSRP is keeping the track of the serial 00 interface of router A. If some reason this port goes down, if there is an issue with the cabling or if there is an issue with the link state of this serial 00 port, that means this command means I will go ahead and decrease the priority of this router by 10. Okay, so whenever there's a problem with serial 00, this router A will have a HSRP priority of 90, which will make this guy a backup router for HSRP. Okay, then the router B will take over and it will become active. Make sense? Perfectly. So there is something else in HSRP called object tracking. So HSRP object tracking is an advanced feature available on Cisco iOS that allows you to track the state of various objects such as interfaces, IP SLA operations, routing protocols, and adjust the HSRP priorities based on their availability. So this capability enhances the network reliability by dynamically adjusting router priorities in response to changes in network conditions. So HSRP object tracking can monitor the status of, again, like an interface or most of the time IP/SLA objects, routing protocols, okay, and you configure the object tracking using a combination of track commands under the HSRP configuration. And again, each tracked object is assigned a numeric identifier and a decrement value, which specifies how much the HSRP priority should be reduced if the tracked object goes down. Okay, so when a tracked object goes down, the HSRP priority of the router is decremented by the specified decrement value. Okay, so what I mean in here, yeah, as we saw in previous slide, HSRP is capable to track the interface. For example, let's say that is serial 00 interface, and I am able to track this interface. If this interface is going down, I have the capability of moving the active gateway to this router. This is we have seen already. But what if, let's say, this interface is connected to ISP routers? This interface and ISP router is connected to another core router in here, and this is connected to internet. So what if, let's say, everything is working fine in this portion of my network. However, there is a problem with this interface of this router 3. Okay, so basically what will happen then, even everything works perfectly fine in here, the traffic will continue flow this direction, but I won't be able to reach maybe the internet since there's an issue with the interface of this router 3. Okay, so HSRP object tracking is addressing these sort of situations. Here is how it's working really. Okay, so this is my local area network switch. You can see in here I have my router 1 and router 2. Okay, and the traffic is flowing maybe from this direction or from this direction based on which router is the active. And then there is one more switch connected to the here, and this one is connected to the cloud, blah blah, and I have one remote router which is 192.168.1.1. okay, so what I'm doing really in here is, first I am defining an IP/SLA to keep a track of this IP address of router 3. What I mean is, you go ahead and type this command IP/SLA monitor 10 and then type echo protocol IP ICMP echo blah 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 frequency 5. Okay, what I'm doing in here, I am generating some SLA monitoring. I'm creating one SLA monitoring. And I am simply starting to ping this IP address from my router. Okay, and with a frequency of 5, which means I will go ahead and ping this IP address each 5 seconds. Okay, and then I'm putting this command and starting the SLA to run, IP/SLA monitoring to run. Okay. Then this command is to track this SLA, track 100 IP/SLA and the monitor number. Then how it works really, this one will try to, my router will start pinging this remote IP address each 5 seconds. Okay, and then in my HSRP configuration, I am doing this configuration this time. Standby 1, track 100. 100 comes from here, whichever I'm using to track the IP/SLA. and decrement 65. So which means in case there is an issue when I'm pinging this IP address, if the ping fails, I will go ahead and decrement my HSRP priority, and this guy will have a priority of 35, and this will be the standby, and this one will be the active gateway for this time. Okay, so this is how it works. HSRP authentication that is used to secure the communications between HSRP routers within the same group. So the purpose in here is prevent unauthorized routers from participating in HSRP operations, and you just go ahead and specify a plain text authentication key using the standby group number authentication and authentication string command on a Cisco device. So this is just ensuring consistent configuration of authentication keys across all routers in HSRP group for proper operation. And this HSRP authentication supports both clear text authentication and MD5 hashing for stronger security as well. All routers in HSRP group send hello packets to each other. Okay, so by default, the hello timer is set to 3 seconds and that timer is set to 10 seconds. It means that a hello packet is exchanged between HSRP devices every 3 seconds. Okay, and the standby device will become active when a hello packet has not been received for 10 seconds. And finally, we will talk about the HSRP versions. HSRP versions are HSRP version 1 and HSRP version 2. HSRP version 1 is the original version which provides some basic failover mechanisms without authentication support. On the other hand, HSRP version 2, it is the enhanced version with support for authentication, multiple group instances per interface, and IP version 6 compatibility. Okay, so that's pretty much it from my side, and thank you so much for listening to me in this HSRP lesson.